Hi, and welcome to our next Level 2 Calculus video. In this video, we're now going to look at the process of anti-differentiation. The process of turning a function into a gradient function is called differentiation. The opposite process is called anti-differentiation. So now we're going to look at taking a gradient function and turning it back into the original function. Right, here's the notation we're starting to get familiar with in this topic. And now we're going to focus on taking y dash and turning it back into y, or dy dx and turning it back into y, or f dash x and turning it back into fx. Right, here are the key rules we're going to focus on. If we have a variable raised to a power of n, we're going to go back and we're going to add 1 to the power, and then we're going to divide by the new power, n plus 1. So if we have x cubed, we need to add 1 back to the power, but then we need to divide it all by 4, which is the new power. If we have a number times x to the power of n, then the number stays where it is. We still add 1 to the power, and we still divide by the new power, n plus 1. So say I give you 4x squared, you're going to add 1 to the power to get 4x cubed, but then you must divide it by 3, the new power of 3. If we have a number by x, you have to add 1 to the power to get x to the power of 2, and then divide it by 2. So if I gave you 5x, you're going to add 1 to the power to make 5x squared, but then you must divide by 2. And finally, if you have just a number by itself, remember we need to put the x back, because when we differentiate, the x disappears, but when we anti-differentiate, the x comes back. So the number 7 differentiates to 7x. Anti-differentiates to 7x. Right, with all those rules in mind, let's go through a couple of examples. Here's example 1. If y dash, the gradient rule, is 3x plus 5, you need to find y. So let's start off with the 3x. We're going to add 1 to the power. It is already a power of 1. So when we add 1 to the power, we're going to get 1 plus another 1, which makes x to the power of 2. And we must divide by 2, which is our new power. The 5 will anti-differentiate back to 5x. The x comes back, and we must add on this number called c. C represents a number by itself. Remember when we do the process of differentiation, if there was a number like 9, when we differentiate it, that differentiates to 0 and it disappears. So when we anti-differentiate, any number that disappeared might come back. So we must add on this number c to represent a number there. So our final answer is y is equal to 3x squared divided by 2 plus 5x plus c. Right, example 2. If y dash is equal to 3x squared plus 2x minus 7, find the original function y. So let's go. Remember that 2x by itself is just x to the power of 1. So let's start off with, we add 1 to the power of x squared to make it x cubed, and we must divide by that new power of 3. For the 2x to the power of 1, we add 1 to the power to get x squared, and we must divide by the new power of 2. And that minus 7 is going to anti-differentiate to minus 7x. The x comes back, and we need our plus c. And in this example, the 3's will cancel and the 2's will cancel to simplify it down to x cubed plus x squared minus 7x plus c. Right, our final example, dy dx, is our formal notation for gradient, and we have to find y. So let's add 1 to the power and divide by the new power, but there's already a number on the bottom, so we're just going to times them together. Don't forget the c to get 4x cubed over 9 plus c. Great. Thanks for watching.